Hello everyone, welcome to the Dhaapps Java course. This is a session in which we'll be talking about the introduction to the OOPS concept. So today we'll be talking about the first concept, that is how to create an instance of a class, what is an object, and how is an object essential, and thus talk about polymorphism, that is the first concept in OOPS, and then we shall further proceed on polymorphism. So first of all, I would like to speak about what is an object. So an object is an instance of a class. So now the question comes, what is a class? So class is basically something that has some certain attributes which define its behavior. Like for a bird, its attributes are, does it has wings? It has wings. It has a beak. Can it fly? What is its color? These are the attributes. And what an object does is that, suppose I create an object of this class bird, that is a parrot maybe. So for this parrot, the color will be green. The question whether it has a beak or not will be yes, it has a beak, it is red in color, and whether it can fly or not and it has wings or not, both will be yes. But again, if we go for another object of a class, suppose we go for ostrich. It has wings, yes, but can it fly? No. So there are various such other uh, conditions which define what an object will do. So we cannot say object 1 is equal to object 2. We cannot say that always. But all of these come from the same class, that is the bird class. So if the class is same, the attributes can be same, but the value for the attributes might be different. Here is where the concept of class and object comes into play. Now coming for this polymorphism, as I told in the previous class, polymorphism is basically one multiple forms of one thing actually. Polymorphism actually means. Poly means many and morph means forms. Many forms of a single thing. So there are various types of overloading in polymorphism, like function overloading, operator overloading. In this session itself, we'll be concentrating only about the function overloading part in Java. So what is function overloading? See, we all know what is a function in Java, right? We will be seeing that in a few minutes. What is more about functions, and there's a short revision of the previous sessions about function actually. So now the question is, a function has a particular prototype. So now if we change that prototype differently but keeping the name constant, we change only a part of the prototype. So that is called function overloading. There is one particular function doing various other forms. So now we'll be going into a code window, and here I have already opened up my BlueJ. So here I have written a code. So public class sum, okay, public int sum. So these are I'll be coming to this part once again, but before that I'll be telling about, see, these are all functions actually. So once again, a recap of the previous sessions. This is actually the prototype of this function. This is the prototype of this, not this actually. This is the prototype of this particular function. This is the prototype of the next function. Okay. So this prototype actually has many parts. The first part being the access specifier, second part being the return type, third part being the function name, and the last but not the least, this part is actually the parameter list. So that is all right, but that is the name of the function again. This is the name of the function. So if one sees properly, that is for all the three functions, that is public int sum, all the three functions, we find that the names of the three functions are the same over here. So I'm sorry it cannot be zoomed, but if we look properly, if we look carefully, we'll find that the names of all the three functions are same, that is sum. So basically this is one single function actually having multiple definitions. This is a function definition, this is a function definition, this is a function definition. So this is basically the concept of function overloading. There is one function, this sum function, doing various types of work actually. So while it can add two integer numbers, it can add three integer numbers, it can add two double numbers and return a double again. So this is actually one function doing various jobs, multiple jobs actually. Now coming to this particular line of code, sum s is equal to new sum. What does this mean? See, this the name of the class is sum. When this is an instance of the class sum s, just like we write int n. Similarly, so sum s is equal to new sum. So it will produce a new instance of this sum class actually. Now, once we create an instance of this class, we get access to everything that is inside this particular class. So we get access to all the three functions. Now the question is, if the names of all the three functions are the same, then how will the compiler decide? Just like it happens, often it happens in many houses that there are maybe two siblings having the same name, two siblings having the same name. Then the question is how to understand which sibling is being called. So here, the compiler actually employs something known as observation actually. So it observes that what is the length of the parameter list first. So here we find in the three functions. So how to differentiate in the three functions? So first, if I separate out this function, how to separate out this function from the rest of the two functions? So this is the only function. This is the only function which has got three variables in its parameter list. Rest all the other two functions have two variables in the parameter list. So when we are entering something in this brackets, if the length of that is 2, then it will go for the other 2. And if it has a length of maybe 3, then it will go for this one. But again, now the question comes how to differentiate from this and this. Both of this have the same two variables in the parameter list. How to differentiate that? So now there comes the next part, that is observation of the data types of the parameters. Once again, there are actually two types of parameters, formal parameter, actual parameters. So this is the formal parameter. Everything that is written here in the function definition is known as formal parameter. And whatever we pass over here is known as the actual parameter. So now looking at the data type of the actual parameters, here we have got double. So moment it sees that both of them are double, it goes for this. Moment it sees that both of them are integer, it goes for this. So this is basically what happens in an event of the function overloading. Now we will compile this particular class. And now we'll look for its output. Let's run it again. One string edges. See, I get the satisfactory outputs also. This only happens if we have got an oops concept, and here I can explicitly call the sum class new sum, and I can name this instance sum1. So here I get another instance, so now I can call any of the functions over here. So if I write here 12, 14 and 18, I get the output which I want. This is what the function returned. So accordingly, since this is actually inherited from this actually has all these objects, and I can inspect this and find that what are the static fields and all. So as there are no static fields over here, so these are all the various features which we will be discussing in the upcoming classes. So that was basically the outlook for the function overloading, and that is actually a part of polymorphism. So this is actually one function doing various jobs. So that is the reason why this is an example of a polymorphism. This is again an oops concept. So as I had mentioned in the previous class, I want everyone to be clear with the basics. There's a theory part so that it becomes easier for this. So I recommend everyone to kind of play around with various codes, whatever they have written till date. Suppose to find out one function I'll write, that is area, and it will find out the area of a circle, it will find out the area of a rectangle, it will find out the area of a square, and such things, and play around with various codes to get a deeper understanding of the whole thing, because this actually takes an enormous amount of compiler space and compiler overhead to compute which is being called when and why. Okay, so that was basically the gist of today's session. So thank you and have a nice day.